This is a very common DWDM interview question. What happens to the signal after every 80 km span? If you can answer this properly, you will cover 4 important concepts in one answer. Let me explain. So when a signal is first launched from the transmitter into the fiber, it is strong and clean. The power is around 0 dBm. The OSNR is high. There is no dispersion. The pulses are sharp. Everything looks perfect. But the moment the signal enters the fiber and starts traveling, things start to change. After 80 kilometers, 4 things happen to the signal. Number 1, attenuation. The fiber has a loss of 0.2 decibel per kilometer. So after 80 kilometers, the total loss is 0.2 multiplied by 80, which is 16 decibels. That is a huge drop. The signal becomes very weak. Number 2, OSNR drops. When the signal becomes weak, the ratio between signal and noise drops. Low OSNR means more bit errors and the BR increases. Number 3. Chromatic dispersion. Different wavelengths of light travel at slightly different speeds inside the fiber. Because of this, the light pulses start spreading out. For G.652 fiber, the dispersion is around 17 picoseconds per nanometer per kilometer. After 80 kilometers, the pulses start overlapping each other and this causes data errors. Number 4, PMD, polarization mode dispersion. The two polarization components of the light travel at slightly different speeds. This causes additional pulse distortion. So how do we fix this? 2 things. First, EDFA. Erbium doped fiber amplifier. This is placed after every 80 kilometers. It boosts the signal power back up. But keep in mind, EDFA also adds some noise, called AC noise. So it fixes attenuation but slightly degrades OSNR. Second, DSP. Digital signal processor inside the coherent receiver. In modern DWDM systems, 100G, 200G, 400G, the DSP handles chromatic dispersion and PMD compensation digitally. We no longer need physical DCM modules. The DSP does everything electronically at the receiver end. So when the interviewer asks this question, mention all 4 problems: attenuation, OSNR degradation, chromatic dispersion, and PMD. Then explain the solution: EDFA for power and DSP for dispersion. And here is a bonus tip: if you mention that modern coherent systems use DSP instead of DCM, it shows the interviewer that you know current technology. That one line will make a big difference. That's it for this one. Subscribe for more DWDM interview questions. See you in the next video.